this video we're going to go through balancing the formula, so the total ionic and net ionic equation. So we've got an example here of this is barium chloride and sodium sulfate. And so we need to work out what the products are going to be in this reaction, and then once we've done that we can then do the ionic and net ionic equations. Okay, so to try and work out what the products are going to be, the first thing I would do would be to look at what ions are going to be present in solution. Okay, so we're not worried about balancing it at this point. We just want to have a look at what ions are going to be present there. So we've got the formula barium chloride, BaCl2. So we know that barium is going to have a 2 plus charge, chloride is going to be 1 minus. So we've got barium 2 plus and chloride 1 minus. Okay. From sodium sulfate, so sodium has a plus 1 charge, and sulfate is a polyatomic ion, so sulfate is SO4 2 minus. Okay, so now we know what ions that are going to be present in solution there. As I said, not worried about the number of sodiums at this point, number of chlorines, just worried about what charges they have. So then we want to try and predict what the products are going to be. So this is where I said it's a bit like a dance where they swap partners. So the cation from one will end up with the anion from the other. So the barium cation here will end up with this sulfate anion. So barium is 2 plus and sulfate is 2 minus. So that's one pair that's going to end up together. The other pair, so the cation here, sodium plus and chloride minus. So we always write the cation before the anion. It's never Cl and A. Alright, so we know that barium and the sulfate are going to end up together. The 2 plus charge and the 2 minus charge balance each other out. So the formula there is barium sulfate. Ba, so 1 barium for every 1 sulfate. So we're not trying to split up the sulfur and the oxygens, they stay together as that polyatomic ion. And the other product then, the sodium and the chloride together, so that's sodium chloride. And again, 1 plus and 1 minus balance each other out, so it's a 1-to-1 ratio there between the sodium and the chloride ion. Okay, so then we can look at trying to balance the atoms here. So 1 barium on each side. We've got 2 sodiums there, so we can put a 2 in the front here. So that has to go in the front. We can't have Na2Cl because then the charges wouldn't balance. Okay, so when we go to balance it now, we can only use the coefficients out in front of the formulas. Okay, so that'll give us 2 sodiums on each side. That means we've got 2 chlorides. There's 2 chlorides, so that's balanced. We've got 1 sulfate, 1 sulfate. So that's all balanced there. So we know from the information that we're given, so both of these starting materials here are aqueous, so they're both soluble in solution. So the product here, barium sulfate, so according to the solubility rules, this one is insoluble. So it's written as a solid, so it precipitates out of solution. Okay, so that's a solid. Sodium chloride is soluble, so it's written as aqueous. Okay, so that there is our balanced formula equation. So then we want to split up the strong electrolytes into their ions. Okay, so barium chloride is soluble in water, so it will dissociate into barium 2 plus ions, and there will be 2 chloride ions. Sodium sulfate is soluble, so it will dissociate into 2 sodium ions and 1 sulfate ion, which is 2 minus charge. In the product there, barium sulfate, it's a solid, so it's insoluble, so it stays as the molecular formula there. We don't break that up into the ions. And then sodium chloride, so we know that dissolves in water, so it's dissociated into the ions. We get 2 sodium ions and 2 chloride ions. So that there is our total ionic equation. So what we then have to look for are the spectator ions. So they're the ones that are exactly the same on both sides. So we can see we've got the 2 chloride ions on the left and right. We've got 2 sodium ions on the left and the right, so they're the same. So they're our spectator ions, so we can cancel those out. Okay? So what we're left with then is the net ionic equation. So we've got the barium ions and sulfate ions that react together to form barium sulfate. So that's the net ionic equation. That's effectively what's going on in this reaction. Okay, so it still needs to be balanced on both sides. So we've got 1 barium, 1 sulfate, 1 sulfate. The overall charge adds up to 0, so 2 plus and 2 minus adds up to 0. Overall charge is 0 on the right side there. So it's still all balanced.